Hello and welcome guys. In this video I want to talk with you about Kafka, specifically how to set it up in Golang. If you've seen all my live streams, I've been using Kafka for quite some time and I use it a lot at my job as well, so I think this is a must-learn tool, at least for backend engineers, and specifically if you're working on more of a microservices setup, the probability is quite high that you're gonna need to understand Kafka. And I will keep this video anyways beginner friendly because I don't want to jump straight away in all the concepts. This is more for people who just wants to use Kafka right away, play around with it and build tools around it. And if I compare it to SQL, this is something if you want to learn how to just save and get data from database, right? You don't want to jump straight away to indexes, common table expressions, sharding, whatever, right? So we will keep it to core concepts. But anyways, we need to talk about Kafka basics, about terminology, otherwise it's not going to be clear what I'm talking about. And I will show you some kind of tricky parts and common errors when you're setting up Kafka. And specifically, we're going to use Confluent-Inc version because I use it in JavaScript as well, and it has a lot of stars in Golang as well, and does everything we need. All right, let's jump into Kafka basics, and then we'll continue with coding. All right, so what is Kafka on a high level? Essentially, you can think about it as it is a message broker plus database, nothing more. So we can publish messages and then we can subscribe to messages. And essentially, we have three main elements. We have a producer, we have Kafka broker itself. This is what people usually refer when they say Kafka, and we have consumer. So producer and consumer are clients which are provided to us, one to publish messages, and another one is to subscribe to specific topic and essentially receive the messages. Right? We will pull from the Kafka and receive those messages. Another important part that within the Kafka we can have topics. So if we are comparing to SQL, this is similar to database table. Obviously, it's not the same, but you can think of it if you are comparing to SQL that this is just a table in the database. And obviously, we can have a lot of topics with different names like orders, delivery, product, I don't know, customer, whatever we want. And within the topic, we will essentially send messages into topic, and we will have these messages, and each message receives an offset. An offset, you can think about it as a unique index, the same like in a database. The only thing, I'm not sure if you can do it UUID, but usually, I've never seen it actually, we usually use just integers. And this is good for us because we can receive data from the database, from Kafka, sorry, in order, right? One by one, each and every index. And this is one of the most important parts, that we have dumb producer and smart consumer. And what it means, that producer just sends messages into topic. That's it. On this part, producer's job is done. However, consumer is smart. We can subscribe to whichever topics we like, and we can consume message at whichever speed we like and from whichever index we like, which means that we have, for example, three consumers, A, B, and C, right? And consumer A receives only, he wants to subscribe only to latest messages. So if he connected just now, he will receive only from the fifth and onwards. So straight away, he will get nothing. And let's say consumer C, he wants to receive from the fourth index. So he will receive basically these two messages. And consumer B, he wants to get from offset 2, or he will wants to get like earliest from 0. And he will replay all the messages. And this is one of the core features, right? We have essentially message replay, and that's why Kafka is a database as well, because it stores messages, and we can replay them at basically whenever we like. However, the important part that we need also to commit messages. Once we received it, we need to commit and say that we consume this message and we don't want to receive anything before it, right? So if, for example, we received message 1, message 2, and then we straight away committed message 5, then all this will be ignored as well. Kafka will assume that all of these messages were already consumed. So this is something to be careful about. I will talk about this in future videos when we will go a bit more deeply into Kafka. But for now, I think this is the core setup. So essentially we have producer, which is dumb. We have consumer, who is smart. We have topics within the Kafka, and we can subscribe to these topics. And within each topic, we have messages with their own respective offsets, and we can consume at any offset we like. All right, let's jump into coding and see how we can implement all of that. All right, guys, so this is pretty much a blank project in front of us. I have just main function and make file with I've adjusted it to run the app. We will use it a bit later, but let's create all the folders we're gonna need. So gonna make it a bit more prettier. We will create CMD, we'll create internal, and in internal we will create producer, we will create consumer, and we will create something like for shared types, configurations, whatever. You can name it differently, right? Different projects I've seen do it differently. Why I'm creating it like so? Because we can have one project using only consumer, another project only using producer. But here I'm going to use both of them in the main, but you can play around with it, right? Most likely you're not going to have in the same place consumer. Well, maybe you will, maybe you don't, right? You can do it whatever you like. So here I will create as well consumer go. This will be consumer. And in producer, I will create producer go. And I'm not going to pretend that I know all these configurations by heart. So we're going to go to confluent-kafka-Kafka's page. You can find it by just typing Kafka confluent go. And this is the first Git repo, right? This is the same I have open here. And in the examples, let's have a look. They are showing us a, this is what consumer. Let's create a producer first. So I'm just going to copy paste it, right? And we will adjust it the way we like. So let's have a look what we have in here. So first of all, go mod tidy. Let's download it. The important part here, and I ran into this issues quite a lot before, you need to make sure that you have a v2 here, otherwise it's not going to work. So make sure that yeah, you have confluent-kafka-go, and v2, and then Kafka. Otherwise it will break. All right. So we have all the packages, and now let's have a look what are we doing here. So in Kafka, we have dumb producer and smart consumer. So we are creating essentially producer. We are specifying host. Very straightforward, right? This is all we need for our producer. Let's panic if we have an error, right? It's going to crash. And then the cool part that we have this function, it goes over all events, and essentially we can get a confirmation that producer essentially delivered message to Kafka itself. And this is very nice, right? Because for some reason you might be publishing messages and consumer doesn't receive them, and you might think that it's a problem of consumer, but it's actually can be a problem of producer, that producer doesn't deliver them. So we can see that delivery failed, delivery succeeded, right? We will keep it as it is. And then we have a topic, and we are publishing messages into the topic. So, and then we are flushing messages. I think we don't need it. Flush weights of outstanding. Okay. We don't need this because we don't want to flush any messages, and we're not going to send like so. We're going to take this part. We're going to keep it in here. And actually, we're going to create our separate Kafka producer. In it, we will have producer, and this will be pointed to Kafka dot producer. And now we will add our methods. Obviously, we will need to create it. So we will split this logic into two, right? One function will be producing because we might use it from somewhere else, like we will import into our main, like a function to produce, and then we will produce from there. And another function is just to create the producer. And let's do this. So first one will be func new Kafka producer. It will take, I think, just a topic. In which topic we want to, for which topic this is going to be a producer. This will be a string, and we will return, and yeah, it should take a, should it take producer? No. Return producer, and we're returning Kafka producer, and let's add a topic here as well. And this will be a string, and we will return, so we will move this logic into there. Let's keep delivery there as well. Confirmation later on we will remove it because it's a bit of a lot of excessive logging. So we will create a producer. This will be with name p, and then topic will be topic. And let's straight away in shared create types or Kafka config, something like this. So we'll create struct Kafka config, and here we will have also topic. string consumer group. I will explain later on what it is. Consumer group, and what else we need? I think this is, and just host. And we'll have function new Kafka config. We'll return Kafka config. And for now, we will have just default settings here. What are you returning? So topic will be just local topic. Consumer group also local CG, and host will be localhost. All right, now in producer we have topic. We will provide here a default topic. Let's just say that if let's say config will be new Kafka no, shed new Kafka config, and if we don't have topic, we will set the topic to CFG. Oh, I made them not exportable. Topic like so, and this will be CFG host. What else we need to change here? I think this is it. So we are creating producer. Now we need to add a, so actually we don't need main function here, right? So this will be K, actually P, Kafka producer, and here we'll have a method produce. We are capitalizing it, and here will be message. I don't know, this will be a string. For now, for simplicity, obviously it can be some kind of struct, whatever you want. Right, so we will say P producer produce, and byte word, and we will say byte message. And topic, right, will be our K. Oh, P. My God. KP. Confusing myself. Kafka partition. All right. So this is pretty much it from the producer side. We are, once again, it's quite dumb. It's quite simple. Now let's just add it into our main function. Here we will create some kind of server. It will have a producer, and this will be pointed to Kafka. Let me just copy it. And this will be producer Kafka producer, and here we'll have a func new server. We'll return our server if I can type, and our producer will be producer new Kafka producer, and the topic, let's just keep it empty, right? Because we will create it with the default configuration. And here we'll say that server will be new server, and this is pretty much it. What else? We will create a function on our server which will publish messages. And we will name it something like produce message. And we will create a ticker that send a message every second. Time new ticker, time second. And every time we are getting a message, so actually this can be a for range. For now, let's make it simple version, ticker.c without any cleanup, but obviously we should do the cleanup. So this will be time, actual time we are receiving right from the channel. So this is time. And let's create a message. This will be a string, fmt sprint f. What we will have here, hello from Kafka, message ID. Let's create some kind of index as well. And we will increment it here. This will be digit ID. And we will also send the date, timestamp, ts equals like so. And we will do t dot format. And here we need to specify in which format, like 15, 20, 20, something like this. So it will understand that I want to see hours, minutes, and seconds in this format. And now we will say that s producer, and did I name it producer as well? Yeah, producer, produce, just produce. Producer, produce, and we will produce our message. And after that, we will increment our index. And now we are sending messages to our producer. And should I do it in goroutine? Probably no. Let's block it like so. What is the issue here? Yep. I'm not passing. What does format returns? String. Okay. So percentage s. All right. So what are we doing? We are creating new server with a producer. Producer will start. Will connect to Kafka, obviously. And we are just sending a message. So we will run it every time the ticker hits. We will run it, increment timer. So here we're adding ID and stuff like this. Here I'm passing empty string. Obviously, this is not the prettiest approach, but nevertheless, for simplicity's sake, let's do it like so. Later on, I will refactor it, and also we need to do some cleanup. At least I need to say defer ticker dot stop, and yeah, we will later on need to stop somehow the ticker if we need to. Otherwise, yeah, I think we are good for now. Let's move to consumer. So the same strategy. We're gonna snatch consumer from here, but actually in consumer, we're gonna change quite a lot. All right, so let's go over the code here. So first of all, we are creating new consumer. We have actually, as I mentioned before, a smart consumer. So there are a lot of options here, and we will walk through the most important ones in a second. So if we're getting error, we are throwing the panic, right? Because we cannot process without it. Obviously, you can change the error for something else and process it normally, but for now, let's keep it panic. Then we are subscribing to topic, and here we are providing a slice of topics. Let's adjust it straight away to, let's do as well. We will create config here. New Kafka config, and here will be CFG, our topic, right? So we are subscribing to the same topic, and here for the local host, we will replace it to CFG, and here will be host. Right, and consumer group. Okay, let's replace all of this straight away, and here will be consumer group. Then we are setting return to true, and while it's true, we are running the read loop. All right, let's actually remove the run, because we will run an infinite loop. And what is happening here, we are reading messages. If we don't have an error, we are processing the message. I don't really like that. So I will say if we don't have if we have an error, if error is not null, and if we are getting an error timeout, right, the client will automatically try to recover all errors. Timeout is not considered an error because it's raised by read message in absence of messages, right? So if we are getting this error, this is actually not an error. So I will say if the error is not null and it is not timeout, then we have an actual error, right? And yeah, we will say consumer error. Otherwise, here we need to process message. And we will say defer c.close, and we will move it after the error, right? And this is pretty much it, right? So we have every second, we are reading from, we are pulling the messages, and we are trying to read from the loop. You can read the description here, right? So read message pulls the consumer for a message and checks if we have a new message. Obviously, you can change the timer to something else, not a second, like more often, depends on you. So we are checking if we have a message, if it's not a timeout, if we have an actual message, we will actually continue here. And otherwise, we will process the message. I will add this logic now, but now let's talk about consumer and what we can do with it. All right, let's start with the after offset reset earliest. And what does it mean? They can be latest as well. And overall, let's say we have a topic 1 and it has messages 1, 2, 3, 4, 5, and 6. So we can create a consumer and specify how would we like to consume these messages. Do we want to start from the beginning, from the earliest? Do we want to start from the latest? Do we want to start somewhere in the middle from specific index? And we can do this for each and every consumer. So we can say topic 1 and like in our case, consumer group 1 will start from earliest. Right? This is in case if offset wasn't specified. And we can create a consumer 2 with different consumer ID, right? And it will consume the same topic, the same 6 messages from the latest. And we can create CG3 and he will start from, I don't know, let's say from index number 2. So we can create as many consumers as we like, and we can consume messages from whichever place we like at whatever pace we like. And this is amazing. One of the amazing things about Kafka that we can do this. So essentially, let's assume we have some kind of e-commerce shop and we have like someone published in a topic order confirmed. And let's say we will have different consumers. We will have delivery consumer, we will have payment consumer, we will have some kind of notifications consumer that will send messages. So basically we can have for the same topic 3 different consumers and they can work in parallel. Then you can like synchronize, right? Finalize the order. That's not important, but the main important thing that you can consume the same topic by 3 different consumers. Well, basically as many as you like. And this is one of the examples. Or you can make a delivery, right? Consumer which consumes order topic and then delivery will publish into his topic and then payment and notification will process it. So there are lots of possibilities. And I think this is one of the important concepts that you can have a consumer group and each consumer group can process the way it likes. But I think auto offset reset is not actually responsible for which offset we are starting from. This is a default if we don't have offset already set. So we can check all the options actually here. Let me open the browser and I will show you the most important ones. So let's go back. So let's take a look at auto offset reset. Yeah, action to take when there is no initial offset, right? So we don't have, it's like a blank topic. Of some reason, the initial offset wasn't set. This is what we do in the beginning. We can set either the latest offset or the smallest, right? And there are other options. The another important part is what we do with the offsets. When do we commit them? So for example, consumer group, right? He processed message 1, 2, 3, 4, 5, but he never committed. Let's assume we restarted our server and he will start once again from 1, 2, 3, 4, 5, 6. So we need to commit messages so we don't process them once again. And this is a question, when do we commit the messages? Do we commit them after we, for example, save something into database and then we commit, or we commit them right away? Most likely you want to process something into database or do some operation and then commit. Probably I will show how to do it in the next video because it's quite extensive and quite long and gonna get overcomplicated. But I think this is one of the important topics as well. So by default, there is auto commit enabled. And if I will show you, yes, enable auto commit. So automatically and periodically we commit on the background. So whenever a message arrives, essentially we have on the background, Kafka runs ticker, I assume, and they commit all the messages that arrived. Regardless, we process them, we got success, error, whatever, Kafka will commit them. And well, should we use auto commit or not? Well, it depends, right, on the application. So for example, let's assume that we have a notification service. It's a WebSocket service, and we don't care if the client receives it or not, right? We just push into WebSocket and whatever happens, happens. If the client is connected, he won't receive it. It's, let's assume, client's problem. So this kind of things we can just auto commit and forget about them. But let's assume we have then e-commerce shop and we have order service. Well, in this case, it's quite important then to process first database operations and then commit. Because if order failed, we don't want to commit it, right? For example, our server got shut down for some reason in the middle of database transaction. We want to reprocess the same message, right? For example, like message 3 failed, we want to process once again 3, 4, 5, 6, and we don't want to lose all the messages. If we would auto commit, right, we restart the server and we won't consume these messages. We wouldn't know about that. So this is one of the examples. There are plenty more, obviously. There is another example from reading from specific offset. This is what I'm going to use in my WebSocket application. So for example, if the client got disconnected and he wants to replay messages from specific topic, right? So the messages were arriving like 1 to 3, and on the message 3, he got disconnected. I want to reconnect him and replay for this client messages from 3, 4, 5, 6 for this specific consumer group. So yeah, there are tons of use cases, but once again, I don't want to go too deeply into it because I want to keep it fairly simple. And in the future, I will make more videos talking about these problems. So for now, let's move further and let's add a message processor. And for that, actually, we need to first create Kafka Consumer. So let's once again create Kafka Consumer. He will have a consumer. This will be pointed to Kafka Consumer. We'll have once again a topic. This will be string. And what else we need? We will need some kind of message channel. Let's keep it simple for now, just a string. And let's add a function new Kafka consumer. And let's snatch this logic out. Write all of this. And we will return C. And to create consumer, this will be pointed to Kafka consumer. We will say consumer will be C. Then we will say topic will be the default topic. CFG topic and message channel. Well, we need to provide a message channel. We will store it in our server. So message channel will be chan of string. And this will be send only channel. Like so. Oh, chan string. Like so. And then we will return consumer from here. We can actually return errors as well and process them in the server. This would be a better approach. So we will return either pointed to Kafka consumer or error. And here will be nil, nil, and nil in here. Right, and this function will be on our consumer once again. And this will be read message loop. Once again, we're reading every second, and here we will take then the message. So let's say payload will be message dot, oh, let's move it here, dot value. We have a lot of metadata on it. I will show it a bit later via debugger, but for now, let's say that c dot message channel will send this payload, and that's it. And value, oh, it's bytes. Alright, we stringify it, and that's it. Okay, this is good for now. Let's go into our main function, and now let's add consumer here. So this will be consumer Kafka consumer. Let's one make it public. Nope. Actually, do we need to? I think we'll keep it private, and we will say in here, go consumer read message loop, like so. Whenever we create it, we will straight away start the loop. All right, and now we will say consumer will be consumer new Kafka consumer, and we need to provide some kind of message channel, and we will create it here as well. So this will be channel string, and we will say message channel will be make chun string, and let's say we'll make it buffered with 64, and here we'll provide message channel. And what's the error? Oh, this returns error. We'll say C error. Provide C here, and if error, we'll just panic for now. But once again, you can process the errors the way you like. All right, and yeah, and we need to assign message channel here as well. This will be message channel, like so. All right, now in the server, we will create some kind of read loop. Func as server. Handle message. And this will accept message string. And here, let's say go function. So probably here you will do some kind of database operation or whatever you have, business logic, whatever it is. For now, let's fnt println or printf received message message. Right, and here we'll create a for loop over our server message channel. We need to change this, and we'll say message here. And we'll just do go as handle message message. And on the second thought, let's move actually this at the bottom. It will block us, and let's produce messages in a goroutine, right? So the ticker will be in goroutine, and here we are blocked until the message channel is closed, which is perfect for us. All right, let's test it out, see how it's going to work. I think there will be errors with consumer, but let's see. And yeah, to do that, we actually need a Docker file. Let me copy it. This is from another project. I've been using it for a while, so let's quickly walk through it, what we have here. So obviously we have Kafka. I'm using confluent-kafka latest version. I'm starting on port 1992, and here is the overall general configuration. This is just boilerplate. The important part here, we have also Zookeeper. This is essentially a manager on top of Kafka. It is responsible for cluster coordination, metadata storage, consumer group management, etc. The latest Kafkas, they actually already have internal solution for that, but Zookeeper is pretty much still default everywhere I worked, so that's why I'm keeping it like so. And Kafdrop UI, it's a UI that allows us to look into Kafka to see our topics, our messages, offsets, etc. We will take a look at it a bit later. So overall, let's run our Docker compose. Kafka YAML app dash d. All right, it's starting up. Will take a few seconds. Let me place for now some debuggers like in message, and I wanted to look at the consumer. Yeah, I want to check out what is in the message because I wanted to show you. Where else? Oh, and actually I noticed a big error, right? We need to place it in here. See consumer. Otherwise we will be closing consumer, right? Before the, or during read message loop. Okay, did it start it? Yes. Now let's make up. Getting an error. Let me place debugger before it. Try one more time. Okay, so I'm getting the error that subscribe topic is not available. And actually this is the error I was expecting, because the first error, I'm not sure what was it about. Nevertheless, to fix this error, basically what is happening? We are subscribing to a topic before it was created, right? So this topic does not exist and we are trying to subscribe to it and we are getting an error. So essentially before that, we need to create a topic, then wait for a topic to be available. Well, we don't need to wait, but we can create a health check, basically a ready check to see if the topic is ready or not. And to do that, actually, I've already written a code for that during one of my live streams. So it's going to be quite a lot of writing. So I'm just going to copy paste it from my other project. And yeah, let me just walk you through it. So what we are going to do, we're going to have a method initialize Kafka topic. And here we are creating a Kafka admin which has a method to create topics, right? And we're gonna create the same topic we need basically. And then we're gonna check if the topic already exists. We're gonna ignore this error, right? There is a NAS error code for that. Otherwise, we will just print that the topic was created successfully, and then we will wait for the topic to be ready. Once again, we will use a Kafka admin for that, and then we will get metadata about the topic with a timeout, and we will check if all partitions are ready. I don't want to go dive deeply into that, what are partitions and etc. So basically, we are waiting for all the parts of the topic to be ready, and once it is ready, we will know that we can use this topic already. All right, let me add this code into our application and see what's going to happen. Right, so we will add it before subscribe. We will say, actually, we will move consumer higher. And we will say consumer initialize Kafka topic. And here we need to provide brokers. So this will be CFG our host. And we need to provide topic, this CFG topic. Now let's run go mod tidy to tidy it all up. All right, we don't have any errors. And now let's check if our application works. Actually, let's run it in debug mode. For that, let's place some breakpoints. We will place them somewhere in the initialize topic. Let's place one on the error, one in the result, so we can see which result we are getting. Wait for topic ready, I think is not that interesting. And then let's go into read message loop. All right, we have breakpoints here already. All right, let's debug it out. All right, so we're getting a result. What we are getting, that we got the topic, error code is nil. All right, so we're jumping here and we're getting that topic was successfully created. All right, we don't need debugger here anymore. And now let's wait for a message. And we got, actually we got an error timeout, but this is expected error. So, okay, I jumped too soon. All right, we need to make an error for error if error is not nil, and error actually is timeout. We will just continue because this is expected. All right, let's run it once again. And let me open the debug console so we can see. As you can see, now we got topic already exists. And probably the consumer is being initialized, but we don't see anything. Right, because we need to wait and it might take a while. So let's just wait for a first message. All right, let me actually stop the debugger because it might take a while, and let me add another piece of my code. I have already checked, at least we will see what is happening in the code. Let me walk you through the code as well. So we will have a loop which will check if we are ready to accept or not. And we need to create a ready channel, and basically we will sleep for a second and then we will run a ready check. Ready check basically checks if we have a consumer assignment. And this way we can understand if length of assignments is greater than nil. Basically, this is the way to check if consumer is ready to accept the messages, if he was assigned. And now let's add, do we need is ready? Probably not. All right, let's leave the is ready, and let's add on the consumer. We'll add a ready ch, will be channel or struct, and we will create is ready. This will be boolean, and let's create them. This will be unbuffered, and is ready will be false. All right, do we have any errors? No, but we are not using this function anywhere. And we will do it like so and jump into read message loop. No, actually, before the read message loop, we will run consumer and we will run ready to accept. So this will actually just show us what is happening with consumer. All right, let's run a debugger once again and see what is happening. All right, so we are getting messages. As you can see, consumer was already, well, it started to accept messages even before that. All right, this looks good. The only thing I don't see that we are producing messages, and this is a bit weird. Let's have a look at our producer. All right, let me place a debugger here. Are we even running it? Yes, we are running the code. Nothing is happening. So what does produce return? It should return an error. All right, let's check out what is the error here. Let's restart debugger. All right, we got an error. Operation not allowed on close. Okay, I didn't move. Defer. Do we need defer at all? All right, let's just keep the client running for now. Producer admin. Let's see what's going to be happening. All right, no more errors. Good. All right, now we are producing. All right, you can see the message was delivered and the consumer is ready to accept. It's not ready to accept. Let's wait for it. All right, takes a while sometimes. As you can see, that's why it's nice to have this ready check, because sometimes I was like stuck during my stream and just looking at what is happening and having no clue that it's actually being in a state of connection. All right, and finally we got the first message. So let's take a look at what is there. As you can see, I sent 56, so we waited almost a minute. All right, so what we are receiving topic partition. We are receiving topic which we are sent to partition. Probably I will talk about partition in the next videos. Offset, metadata, error, and leader epoch. I'm not sure what is that, but nevertheless, we got our message. It was the ID null, the first one, right? So there we are receiving them in order, timestamp, and pretty much this is the core information we need. And now all the messages will be sent. I think I will get the timeout error right now because I was stuck too long on debugger. And now we will get, yeah, all the messages printed. And essentially, this is Kafka already working. Yes, as you can see, we are sending messages and we are receiving messages. So consumer, producer are connected. All right, so just to summarize, as you can see, received message, where do we have it? We have it in handle message, which we are receiving from the message channel. And in the message channel, our consumer is publishing the messages, right? So we are in fact receiving messages and also getting delivered message. This is the like a confirmation from producer that the message was in fact delivered into Kafka. Do you need this stuff? Maybe, maybe not. If you have an application with only producer, it's nice to have a delivery message, right? But if you have a producer, consumer, well, basically it's up to you to keep it or remove it. I think it's nice to have it, a double confirmation that producer is actually working, because you saw like the error I just got that I was not receiving these messages. So for me, it was straight away clear that I'm doing something wrong with producer. And then, yeah, I fixed the error. And now we can see that we're getting this confirmation that message was delivered. Also in consumer, right, I added we need to create a topic before we subscribe to it, because, well, there are options to provide in producer actually to create topic on creation, but in consumer, there are no options like this. So you can create on the new consumer, you can pass in options for producer. Where is the producer? In here to create the topic. However, in consumer, you don't have this option. So anyways, you need to have this health check and creation of the topic in the consumer. And lastly, I created a ready check just to see in the logs, right? Because you saw it's sometimes taking really long time. Let's try it one more time. Make up, and let's see how long it will take this time. So now we're getting topic already exists. Once again, status false. All right, now it connected way faster. And actually, we start receiving messages even before the ticker here hit in the ready check. And now we are receiving messages. As you can see, message was delivered, and straight away we are printing that message was received. So in this video, I think I'm going to be finishing with this setup. I wanted to make just a basic configuration to show you some kind of tricky points with timeouts, with creation of the topic. Although I've done this several times myself, but as you can see, still I'm getting errors. Nevertheless, in the next video, I want to go over some of the more realistic world examples. For example, if we have a database and we need to write something and then commit a message, and what happens if we crash in the middle of database transaction, how can we consume the same message again and basically not lose any information? Or how can we have multiple consumers? How can we essentially read from the beginning, from the any index we want, from the end? And yep, if you enjoyed this video, please consider subscribing to my channel so you won't miss out the next video. For now, thank you for watching and I'll see you next time. Take care, guys. Bye-bye.